talk multiplying matrices. So I kind of made this a discovery lesson to begin with. When multiplying matrices, they need to be compatible with each other. Try to figure out which dimensions of matrices are undefined and why. So talk amongst yourselves. Tell me which ones are undefined. I realize there should be a multiplication sign here. I realize you haven't learned this, but I want to see if you can discover it without me just telling you. Okay, so Evan says that this one and this one don't match up, these two match up. So these are both undefined. Okay, what if I was to tell you this? Only one is undefined. Here's another hint. If there's only two that are defined and one is undefined, try and find the similarities between two of them. Ryan, why are you saying it's the first and the third?
Because A ends with a 5 and B starts with a 5, so they both have that 5, and then R that and starts with 2.
So the inner dimensions match. So this, when I multiply these two matrices, I will get a 3 by 2. See how it's the outer dimensions? And when I do these, it'll be a 3 by 22.
So it would be the middle.
This is undefined. Which one is undefined? The middle one is undefined.
So all the ones that don't, like the terms don't match up, then they're all undefined.
Yep. Got it?
Why?
You'll see why. Yes.
Undefined and does not exist.
They are not the same thing.
Okay.
Okay. So when you're adding and they don't exist, why?
They don't have the same.
Because they don't have the same dimensions. But multiplying, there's like a key to the dimensions. The middle dimensions have to match. They have to line up. Okay? You won't see it with the first square matrices because they're both the same dimensions. You'll see it when we move on. So this is a 2 by 2, right? And this is a 2 by 2. So when I multiply, I should get another 2 by 2. Okay? All right. So here's where it starts to get complicated. I'm going to do kind of a sketch of what this should look like. A template, I should say. So I'm going to multiply my first row, row 1, times my first column. So this is my first row, and this is my first column. Let's do row 1, column 1. Row 1 times column 1. Then I'm going to continue on. I have not finished with row 1 because I still have a what? I still have a column 2. So I'm going to multiply my row 1 times my column 2. Am I done with everybody? What do you mean no? I hit column 1, I hit column 2. Now that I've hit column 1 and column 2, I'm done with row 1. Moving on to row 2. Row 2 needs to be multiplied by, what do you think? Column 1. Row 2, column 1. Now what do you think I need to multiply row 2 by? Column 2. The book says, I think, x1, y1 times a1, b1, x1, b1 times, right? Very confusing. I think this helps a little bit more. Okay, so let's do it. I would leave your matrix open first. So row 1, column 1, let me give some color on this now. I'm going to multiply row 1 by that first term in column 1. Then I'm going to multiply my second element in row 1 to the second element in column 1. Don't say you're lost yet, okay? So 3, I'm going to write it all out. 3 times negative 2 plus what? 2 times 1. That is my first element in my new matrix. Okay, now I'm going to move on to column 2. See now how I'm doing row 1 times column 2? I'm going to ignore this one right here. I'm done with it. I'm not even paying attention to this either right now. You see that? Sometimes when you're doing this in college, you'll see people are doing this. You know what they're doing. They're doing matrices, right? Because they're covering things up and looking at rows and columns. Because this is just the beginning of this. There's a class in college just on this. Okay, so I would multiply 3 times 1 plus 2 times negative 1. The reason I write it all out is you get really confused when you're multiplying and adding at the same time. So I suggest you just write it out. Okay, so now I'm done with row 1 completely, right? I hit C1, I hit C2, I'm done with row 1 completely. Moving on to row 2.
Wait. We won't file like row 1 times the 2 columns.
Row 1, column 1, row 1, column 2. Done with row 1, so I'm going to go ahead and cover it up. Done with it. And moving on to row 2, column 1. So row 2, column 1 is negative 1 times negative 2 plus 0 times 1. Done with column 1, moving on to column 2. Negative 1 times 1 plus 0 times negative 1. Go ahead and take those off now. Equals. I still don't skip steps. I'm telling you, I make mistakes all the time when I'm doing these. 3 times, I think I made like 5 mistakes in the last class when I tried to go fast. 3 times negative 2 is negative 6 plus 2. This one is 3 minus 2, right? This one is positive 2 plus 0. This one is negative 1 plus 0. Especially these. When I say plus and I see a 0 and a negative 1, I keep wanting to say plus negative 1 instead of plus 0, and I don't know why. Get it? Equals 6, negative 6 and 2 is negative 4. 3 minus 2 is 1. 2 plus 0 is 2. Negative 1 plus 0 is negative 1. Questions? Yes. Did you not just hear what I said?
You know, if you do all the steps, you'll be better at it, and you won't forget it, and then you won't complain more about a bad grade. She's just making her life easier now.
I'm not making my life easier. I'm making your life easier. I would hate for something as simple as matrices, simple operations, I would hate for you to do poorly on the test because you want to be lazy and skip steps. Is that better said?
Yeah.
Thanks. All right, so let's have you try one now, but I'm going to set it up with you first. Okay, let's write a template together. So our template is row 1 times what? Column 1. Row 1 times column 2. Does that cover all my columns? Yeah, so now I can move to row 2. Row 2, column 1. Row 2, column 2. Hey, I want to show you guys one thing really quick. Hey, check this out. Do you see how these numbers are the same? Negative 2, 1, 1, 1, 1, negative 1. And these are the same? 3, 3, 2, 2, negative 1, 0, 0. Yeah, it's always going to be that way. So if you're trying to see if you did it right, everything should line up. Your second ones should line up vertically. Your first ones should line up horizontally. Okay, so why don't you guys try that one? Okay, so this is what you should have gotten. 8, 6, 2, 1. So go ahead and pause if you need to check your work. Questions, anybody? Okay, let's move on. All right, so 3 teams, what? Huh? Oh, just complaining. Okay. Yes. Say it again. A 3 by 2 and a 2 by 3. Yes. We're going to do things other than square matrices right now. Okay, guys. So 3 teams competed in the final round of the Chess Club's championship. For each win, a team was awarded 3 points, and for each draw, a team was received 1 point. Which team won the tournament? All right. So here's your wins and your draws and your teams. So this kind of shows you how you can take real-life matrices and put it into application with something that you can just figure out in your head, but we're going to do it with matrices. So does everybody see that this is the wins for the blue, red, and green, and the draws for the blue, red, and the green? All right. It said that you got, for a win, you got 3 points, and for a draw, you got 1 point. Is this going to be a matrix if I multiply these? Let's count. This is a 3 by, and this is a 2 by 1, so what is the result going to be? A 3 by 1. It is. So, sometimes it's easy to do that because then you say to yourself, oh, let's do a template. I know it's got to be a 3 by 1. There's going to be 3 elements by 1. So it's going to be row 1, what? Column 1. There's no room for another column, right? There is no other column, right? There's only one column. Then it's going to be row 2, column 1, and row 3, column 1. So let's do that. 5 times 3. This one's a little bit easier to do, right? If you were to do it by skipping steps. 5 times 3 plus 4 times 1. And if you look at that, guys, 5 times 3 would be multiplying 5 times how much are wins? 3. And how much are draws? 1. See how that works? Then your next one is multiplying. Why? Okay. Your next one is multiplying. Your next row is multiplying 6 times 3 and 3 times 1, right? So we're multiplying 6 times 3, and we're adding that to 3 times 1. I almost got lost for a second. Finally, 4 times 3. Do you guys see the correlation? Plus, most of you would say it'd be so much easier if you just did it that way. Yeah, it would be easier. That's what makes when you do things that are easy with matrices, then you can look and see, just by looking at it and making sense of it, was I correct? Does that make sense? Do it with the easy ones so that you can do it with the hard ones and understand it. Okay, so 4 times 3 plus 5 times 1. Equals 15 plus 4, 18 plus 3, 12 plus 5, am I correct? Which equals 19, 21, 17. Who won? Red. Let's highlight it in red. Red's your winner. Questions? Would you rather copy this one down or do one on your own? Okay. Here's one for you. Here's it. Okay, so some of you may want to do it this way. Once you set it up, I know I've got a 2 times a 1, that's this one, a 3 times a 2, that's this one. Then a 2 times a 3, that's this one. At this point, if I were to move on to 5 times 1, wouldn't that be a 1 here? And wouldn't this one be a 2 times 1? So it would be 1, 1, 1, 2, 2, 2, 3, 3, 3, right? If you feel like filling it in that way, you can do that as well. So that would be 5, then 1, then 0, 2, then 4, then 5. Once you see the pattern, sometimes it's easier like that. Equals 2 plus 6 plus 6, 5 plus 2 plus 3. No.
0.
0. I wrote 0 and said 3.
The smaller you're trying.
I'm trying to go too quick. 2 plus 8 plus 15
I will wait.
equals 14, 7, 25. Oh my God, Evan. If you use your calculator, you're so fired. This is 3rd grade math, right?
It looks like a third grader.
No, it's 3rd grade math. No calculators. Okay, good. All right, guys, we got to keep going. Okay. I'm going to do this one quickly. What are we looking like on time? 10 minutes.
Don't be so negative.
I know what I'm going to do. Please listen up. I'm going to give you the answer to KL. We need to figure out whether the commutative, the associative, and the distributive property work for multiplication. We're going to find one out together, and then the other one you'll have for homework. So I'm going to give you what is KL, because I've already done KL. Give me one quick second. KL is, you guys get what I say by KL? K times L? 5, 10, -9, -4. So let's find out what L times K is. That would be the commutative property, right? K times L and L times K. So K times L would be, let's see here. If this is a 2 by 3, and this is a 3 by 2, what am I going to end up with? A 2 by 2. You guys are so smart. A 2 by 2 with row 1 times column 1, row 1 times column 2, row 2 times column 1, bless you, row 2 times column 2. A little easier now? I'm just going to erase this now. Bless you. So I would get -3 times 1 plus 2 times 4 plus 2 times 0. Next row, -1. Wrong.
Yeah.
Thank you. It just seems too long, right? -3 times -2 plus 2 times 3 plus 2 times -1. Does it help if I put color from the get-go?
Doesn't matter.
No? Just so that it gives your eye the whole column row thing? Yes, Mr. Smaller, we love when you give us the color. Okay. What's the matter?
Is it easier? Oh, I think it's easier that you take like the column and next -3, 2, 2, and like turn it sideways and put it next to it, and then multiply them. Yeah, and then I try to go straight across sometimes I have to catch myself. You know what I mean?
Like this?
Like, yeah, turn it over. Like,
That is a good strategy.
And then just put the multiple.
Yeah, that is a good strategy. And then do it for the other side, and then erase it and do it for the next one. Awesome. All right, let's see. 54%. I think that matches exactly what the test was. Thank you.
I got it right.
Okay. Did you guys, when you guys were talking though, did you see what else I was doing? Janelle? You've also got this. I think you didn't because you were talking. Once you find the pattern, check this out. This is always going to match. 1, 4, 0, negative. See how the second part of the multiplication is the same? Then these would be the same as well. So this would be negative 1, negative 2, 0, negative 1, negative 2, and 0. So I'm just putting, right? They should all match. 1s, 4s, 0s, negative 2s, 3s, negative 1s. Then 3s, 2, 2, negative 1, negative 2. Uh-oh, that should be negative 2. And 0. All right, moving on. All right. What, Evan? I can't hear you. Okay, so this is negative 3 plus 8 plus 0, 6 plus 6 minus 2. Am I right? This one is negative 1 plus 8. Please stop talking. Plus 0 and positive 2. Negative 2 times 3 is negative 6. You have to tell me where you're at.
Right there. The second one on the bottom. Row 2.
Row 2.
Yeah, right there. Isn't it negative 8? Because negative 6 times positive 4.
That is negative 8. Thank you. Thank you, thank you. See? Made a mistake. All right. 8 minus 3 is 5. 6 plus 6 is 12. Minus 2 is 10. Negative 8 and negative 1 is negative 9. So is it commutative? Does the commutative property work?
Yeah.
Okay, so we just figured out that the commutative property does work, yes. In your homework, you've got to find out if associative property works and distributive property works. There's only 4 problems like that, okay? All right, so what makes a matrix undefined when multiplying matrices? When the inner dimensions don't match. Good. Predict if other properties of multiplication will be equivalent, why or why not. Predict. That's what I want you to write down. Write a prediction. Yes, I think. What are the other properties? Associative and distributive. Do you think they're going to work? Predict. All right, good job, guys.